This video is all about noise. Instead of using the displacement map from the previous video, I'm going to create my own custom noise function by using jit.gl.bfg, well, 3 instances of jit.gl.bfg in order to add movement and offset and zooming in and different basis functions. This will make it possible to change the noise in real time, to change the displacement map in real time, to create cool images, cool movement within the displacement of the original image. And just changing the basis function is going to create a bunch of different displacement effects that are really cool to look at and also really cool to play with and customize and create creative things with. Okay, now I want to focus on this image right here. This is something I called the displacement map in the previous video, meaning that this was kind of our lookup table for displacing, distorting this image. It was distorted according to the color values inside this picture. And I have also said that I've taken this from Touch Designer. This is a 3D Perlin noise function or an object or a top or a chop or whatever from Touch Designer. But in Max, this is just an image. I've downloaded it. I have dragged this image into my Max patch. It's created an instance of fpeg and it loaded this picture inside. What I want to do is different though. I don't want to use this. In fact, I want to be able to create my own noise function so I can change the nature of distortion in real time if I want to. So I can try different parameters, different kinds of noise, different movement within that noise, which should give me a bit more control over what's happening. So I'm going to delete this and I am going to explore in which ways I can create noise in jitter. And perhaps the easiest way to do this is by, well, jit.noise. It generates white noise. It's very simple. The syntax is incredibly simple, as I've done it in my previous videos. It's the same as inputting a jitter matrix, so the amount of planes, the data type, and then the dimensions. And when I do this, if I send a bang, it is going to send a jitter matrix containing random values. Right? So if I connect this outlet to jit.p window, each time I click this button, each time jit.noise has received a bang, it is going to generate a matrix, in this case with 3 planes, meaning that each cell has 3 random values. And the size of this is going to be 10 to 10. If I want, I can make it to 100 to 100. If I want, I can make it 1000 to 1000. And if I'm doing this at a slow rate like I'm doing now, this is fine. If I want this to happen let's say on each frame, so 60 times per second, our CPU is going to start to struggle and become hot and we can crack an egg and eat a nice omelet with it. But for generating random value and just noise, just matrices containing random values, this is very ideal. However, the drawback is that these are completely random. There's no rhyme or reason to it. It's just random values between 0 and 10, and we can't really get any kind of smooth random motion out of these values. Now, a better way to do what we want to do might be achieved using jit.bfg, a basis function graph. So this object, as it says here, it evaluates a procedural basis function graph. And this is kind of like the bigger, cooler brother of jit.noise. It doesn't do what jit.noise does, but what it does much better and in a more versatile way. And to initialize this object, we, just like jit.noise, have to put in parameters appropriate for a jitter matrix. So let's say again 3 planes, float 32, and let's make it 100 by 100. But if I just do this, if I bring over my jit.p window here, if I send a bang, I don't think anything will happen. Nope, it's empty. It's probably not even sending out the jitter matrix because jit.bfg needs an additional attribute called basis. Because this uses basis functions, it will want to know which basis function it can use. Using different basis functions are going to create different kinds of random patterns that we can use. And to begin with, I'm going to use the simplest, maybe the basis function, which is noise simplex, something basic like Perlin noise. And if I give it this attribute, now banging this is going to create this nice image here. Now this is semi-random, right? I mean, this is like a picture, but it's a bunch of random colors, but they're not as random as jit.noise. They're going from one to the other. Another thing to notice is that jit.bfg, no matter how many times I click this button, is sending out the same image. Unlike jit.noise, jit.bfg knows what it's sending out, and we have to traverse this field of semi-random values by using jit.bfg's attributes. So I'm going to start by sending out some consistent bang messages. Metro functionality of jit world is what I'm going to use. So I'm going to create a s metro send this message to the receive object that's going to be entitled metro, and I'm using the second outlet of jit world, which is going to send out a bang per frame. And here I'm going to do r metro. So now this jit.bfg is receiving 60 bangs per second, I believe, so it's going to continuously refresh as we are changing its attributes. Okay, now to traverse within this jit.bfg, I can use the offset message, right? So pack offsets, and let's say 0, 0, 1 for the x-axis, 1 for the y-axis, because we have a 100 by 100 matrix, 2 dimensions. And this is done by the way of floating point numbers. And now if I'm changing this, as you can see, I'm kind of scrolling through this image, this pseudo random noise image, and this can go on until infinity. I can change this to get different states of this picture, which can provide me with random values that are slowly changing. If I'm slowly incrementing or decrementing this value, there is this feeling of movement through random values that I cannot achieve with jit.noise. And we can do the same thing with the second value, which is going to control the y-axis. Let's see, another cool thing would be to explore, let's say, the scale, right? I believe we can also make a message that says scale. It can receive 3 values, or in this case 2 values, because this is a 2D jit.bfg object. And let's see if doing this changes anything. There we go. So now I'm changing the scale on the x-axis, and now I'm changing the scale on the y-axis. Right, so I can kind of morph the picture in this way. If I want just scaled things in general, I can send the same value to the both of these values on the same value on the x and y-axis. And if I want, I can zoom out and zoom in this picture. It's really useful, and these are all, randomly, procedurally generated random values. A lot of video games use this to generate random maps and terrain and water textures and mountains and so on. But what's the coolest thing? Well, the coolest thing about this jit.bfg for me is the third dimension. So think of it like this. What if I gave this a dimension of 100 by 100 by 1? Right, and I, scaled this yet again. It looks slightly different, but it doesn't look so different, Looks the same, but this has an extra dimension, right? So it's the x, y, and the z-axis. And the z-axis here is just, 1 cell deep, so, it doesn't go very far. But the fact that we have a third dimension here means that we can use a third value for our offset message. And changing this third offset message creates a cool effect of the images just shifting, transforming, and moving, not to the left, not to the right, not up and not down, but on the z-axis. So it's like we are going through different slices of this noise, which for us provides this image of a constantly moving and shifting random values. If I want, I can automate this by using jit.time, which is going to output floating point number time values. So for each second, this value is going to increment by 1. And what if I plug this in the third number of my offset message? And suddenly I have this very cool movement that is being generated in real time. If you want to explore the different basis functions of jit.bfg, there's a really easy trick you can do. You can right-click the inlet of the object, which brings up this complicated menu, and you can find the basis message here. You can click it, which is going to create an instance of the attrui object, an attribute UI object. If you lock the patch, and if you click on noise simplex here are all the different functions that you can use. Not all of these will work out of the box. Sometimes you have to feed a texture or a matrix inside jit.bfg. I'm not going to get into this right now, but I can try out this fractal, multi-hybrid, fractal hetero, fractal multi-ridged. Let's see, noise cell, so these kind of cell values. noise checker. Let's see, and of course noise Voronoi, which these create all these cool different kinds of effects that we can utilize in our distortion patches. But here's the thing, jit.bfg has a big drawback, and that is the fact that this runs on the CPU, right? And CPU isn't really equipped to deal with images, especially complex images, they are being generated in real time. So let's say I wanted to make this 1000 to 1000, right? I want to increase the resolution. It's starting to lag. And if I wanted to do it at my, let's say, native resolution, 1920 to 180, it's still receiving the same messages, but this is really choppy, and the max patch itself is lagging as well. And that is because this is too much for my CPU to handle. You might have a good CPU, but you're eventually going to run into this problem. So with jit.bfg, it's always good to have these lower values, or use these not for the visuals, but to generate values for movement of jit.gl objects, or scale of them, or you can change the color of these objects as well. Now, we are going to look at a third object, which is going to be our savior in this case, which is jit.gl.bfg. So this is procedural basis function texture generator. The only difference is that jit.gl.bfg runs on, well, it's GL, so it runs on the GPU, it runs on the graphic card, meaning that it's much easier for it to determine these textures without lagging the computer by keeping everything on the GPU. This means that this is a shader, and the biggest difference is that, well, it has a bunch of different parameters and syntax that we have to use. So let's figure this out. So first of all, I need to feed jit.gl.bfg a texture. This is, like I've said, a shader, and like our shader here, we also feed it a picture in order to process it. Jit.gl.bfg is going to expect an empty texture, and we can create an empty texture by creating an object that is called jit.gl texture. Good old OpenGL texture. And while we create it, we can also define the dimensions by using the dim attribute. So the dimensions of this texture is going to be the resolution of the noise we are going to get out of jit.gl.bfg. So to start with, let's make it 500 by 500. Right, and then I'm going to, since this is a texture, it is always better to see this in this window right here. So I'm going to take this jit.gl video plane, I'm going to sever this cord. I'm going to put it here instead. So let's see in this window the output of jit.gl.bfg. And I'm also going to connect my R metro, so we send a bank to send out this jit.gl texture, which is going to be processed through jit.gl.bfg, which is going to arrive at jit.gl video plane. Okay, not very impressive, is it? It is Perlin noise. It's super zoomed in right now. So this is the first thing. jit.gl.bfg by default, I believe it runs noise Perlin, and it is super zoomed in. We control jit.gl.bfg not by specifying jitter matrix parameters and dimensions and planes, but by changing its attributes. So let's start by the zoom attribute, right? I can change the zoom factor, so I can kind of zoom out and see this noise in more detail. And I'm going to do this by sending a single value. All right, and here comes a floating point number, and we are zooming out, and as you can see, it's Perlin noise, a bit blurry, but consistently random. If we want, we can change our basis function, right? Can create this, which is going to create the attr UI. And then I can, let's say, try your good old friend noise simplex. There you go. I can try noise checker, a nice checker pattern. Or fractals from before, or Voronoi noise, or Voronoi crackle. A distorted, maybe we can use the distorter image by using a distorted texture. But you will notice that these aren't really colored, right? We are going to get to this later, but an important thing and the biggest drawback of jit.gl.bfg is it has one plane, it is one-dimensional, it's just black to white. Right, but before we do that, let's see how we can deal with the offset message. So again, I can just copy my offset message, but I'm just going to use the first two values. right? I'm not going to go into the Z value because it doesn't really exist in jit.gl.bfg. But if I want to change the offset, I can simply use the same offset message. That's still works in the same way. We can change the y-axis, we can change x-axis, and we can kind of move through this noise in any way that we want, at any rate that we want. But to make it change over time, we are not using the third dimension of our offset message, but instead we are using a message called time. Right, I need to send a message to jit.gl.bfg called time, and this will, I think, this is going to determine how jit.gl.bfg's output changes over time. So if the time value is different, this texture is going to be at a different state, and if this time value is continuously increasing or decreasing, it is going to, it's going to look like it is moving. And again, just like how I did before, I'm going to create my jit.time, and I'm going to tie it to my time message, and here is a really nice floaty distorted texture. It already looks a lot like water to me. We can have it with our noise.cell or Perlin noise or noise simplex. It's a great way to create textures that have a lot of variety and movement in them. If we want, we can also copy our jit.time, and we can also use it to derive the x and the y value, so it's it looks like it's moving even more. If you're interested, or if you want to get a bit more into these ideas, you can see how you can change the offset and time by using other parameters, right? Maybe playing a certain chord on your MIDI keyboard will make this go faster or slower. It's going to make it move at a certain direction, etc. But let's get back to the issue at hand. Right now, this is one-dimensional. Right now, for now, I'm going to delete these guys. This is going to be included in the patch. That will be in the video description down below, so don't worry about it. But right now, I am concerned about this black and whiteness. Right, and while I'm tidying things up here, I can consider what to do, and what I can do is to look at the attributes, right? And I can see that there's an attribute here called colorize that is toggled on or off, and if I turn it on, there is color, but it doesn't really look like our distortion map from the previous video. In fact, what I believe colorize is doing is just, interpolating between two colors using this one-dimensional noise. So 0 is one color, 1 is one color, and any number between 0 and 1 kind of morphs from one color to the other. If you're interested in this kind of colorization, there is an attribute that is called palette, I believe. Let's see if I can find it. Yep, palette, which is going to have 3 values, and I can change these values in order to change, well, the palette of this colorization. However, this colorization is not real, as in the red, green, and blue planes of this noise do not have different parameters, different basis functions. It's all the same, it's just a colored version of the 1D noise function. But remember, what I'm doing in my jit.gl pix is I'm taking the red and the blue axis of my second input, which is going to be this displacement map. So ideally, I want at least 2 dimensions that have different noises in them. So to do this, I'm going to go back into jit.gl pix. So we're going to create a little shader that takes multiple instances of jit.gl.bfg and kind of combines them together in order to achieve a 3D per noise function. So I'm going to create my jit.gl pix, and let's think about this. So what I want to do is, well, first I'm going to reinitialize because I don't want it colored. I can also just type in the zoom and the offset amounts as attributes. So let's say zoom 10. Right, and I'm going to delete these messages for now. Okay. So what I want is to have 3 instances of this jit.gl.bfg, and I want each of them to have a random offset, so they're not literally on top of each other, but they're showing different images. And then I want to put them through jit.gl pix, so they're combined into one texture containing the RGB values, each one taken from a different jit.gl.bfg input. I believe this will create an image that will be very close to our distortion map from the beginning. Okay, so let's just take this. Let's make 2 copies of this guy. And now let's give it a random offset. Right, so I want to create a message. So let's say pack offsets. And I want these values to be random when I initialize my jit.gl texture. So I'm going to, let's say, jit random number that goes from 0 to, I don't know, 100. Right, and I'm going to give this as an offset to both x and the y-axis. And I'm going to do this twice, so both my second and third jit.gl.bfg receives these values. I just noticed I'm sending this offset to jit.gl texture. That's a big no-no. This is much better. I want it on my jit.gl.bfg. Okay, there we go. And I can put in a nice load bank. So each time I start the patch, different random values are loaded to my jit.gl.bfg. So it is always going to look a bit different. All right, nice. We can also visualize what's happening by creating jit.p windows here. So I can create this and I can create that. I can make this a bit bigger so it's easier to see. There we go. We don't need this window right now. I'm going to hide it in the corner here. Okay, and now let's just take the output of our metro coming in from jit.roll, and right now both of these images look the exact same because we have not given it a random offset. But I don't even need the button here. If I lock this patch, double click on load bank, each time I click it, this is going to be different, and this is going to be different as well. Now they're not the same textures anymore. So we have dealt with this problem. Okay, so now let's take all of our friends, all of our 3 jit.gl.bfgs, and smash them into jit.gl.pic. So I'm going to open my gen patcher, and I'm going to delete this plus operator. We don't need it right now. And I'm just going to see what I have. So I have 2 inlets and 1 outlet, right? So far so good, but I do need a third inlet because I'm going to be receiving 3 different textures coming from 3 unique jit.gl.bfgs. So let's create in3. And then let's think how we can kind of combine these together into a vector or, well, texture, but I spoiled it by saying vector. I just need to create a vec, which is going to pack the incoming values into a vectors. And I can say vec 0, 0, 0 to denote the RGB values. I don't think I need the last 0. I don't think I need a 4th 0. We will see if that is necessary in a second, but creating this is going to initiate this vec object with 3 inlets. So maybe if I do this, this will work without giving me a lot of headache. Okay, let's bring our displays here and let's see what this sends out. Voila, great, fantastic. So this already resembles our friend from the beginning. This already looks like a 3D noise function that is running on the GPU because that's what it exactly is. All right, and then if I'm going to send one attribute to a jit.gl.bfg, I want to send it to all of them, right? So if there's time messages being sent to jit.gl.bfg, it should be sent to all 3 of them. So these guys are moving at a constant rate. If I'm going to change the basis function, I can connect this to all my jit.gl.bfg so that when I change the basis function, they are changed for all instances, meaning that our colored result will be like that as well. I really like the fractal function when I do this. This is a really cool texture. We can check out the cell. This is pretty much jit.bfg, but running natively on GPU, which means CPU power is saved. Checker is checker. It's just shifting. Fractals are cool. We can look at Voronoi noise. It's really cool. Voronoi crackle is somehow even cooler. Or distortion looks less like water and more like petrol now. All right, so we can take this image and we can load this as our distortion map. Right, so let's do just that. I'm going to connect the outlet of jit.gl.pics to my jit.gl video plane, and the result of all of this operation is going to go into the second inlet of jit.gl.pics. And look at this. Look at how beautiful this is. Now it really looks like it's shimmering and moving and being distorted. And I can change the rate of this distortion. I can change it back like I did before. I can connect it to my microphone, but then I have to check if I have the right microphone on. And I do not. Scarlett Solo USB, and now me speaking is also kind of sort of changing the distortion. Right, and now the cool thing is when I change this distortion, as in when I'm changing my distortion map, distortion is going to change as well. It's Perlin noise, simplex noise, noise cell. So look, this creates this nice pixelated effects. Fractal, as I've said, creates this really cool distortion effect, or Voronoi noise. These will all create different distortion profiles. And starting with this, you can really play around with these jit.gl.bfgs, maybe with each, you know, on each instance, you can give them different parameters. You can do distorted like this, distorted 2-axis, and so on. So there's a lot of things to be played around here. There are a lot of creative opportunities as you're exploring these distortions. And maybe you are good in jitter and you're going to say, but wait a minute, all of these videos are a sham, because jit.gl.bfg already has an input distorted function which takes a texture input and it distorts it, right? So we could have done all this by using a single jit.gl.bfg. But the thing is, since we have kind of reverse engineered this distortion process, the next video is going to be feedback. We are going to look at how we can utilize feedback to have distortion maps that are moving around, flowing in and out of the screen. But until then, thank you for watching.